We are back with topic 3. This is Mrs. Vogt again. And we're going to be talking about rational equations. So hopefully you remember rational numbers are numbers we can write as a fraction. So oftentimes, even whole numbers like 1 over 1, 2 over 2, stuff like that. But other than that, things like 1/2, 1/4, things that aren't rational. Pi, not rational. There's a letter E, not rational. Square root of 2, okay, not rational. So rational is kind of synonymous, at least in this situation, as fraction. So I'll put a little box over here, and I want you to, somewhere on your paper, be able to identify the least common denominator. And if you just call it common denominator, I'm fine with that too. But as we're looking at a common denominator when we add fractions, we need to determine the least common denominator. For example, 30 could be a denominator that I would choose because 3 times something is 30 and 5 times something is 30, but that's not the least. So we always want to go with the smallest. And in this case, we can't find a common factor for them. So 3 times 5, 15 is my LCD, or my common denominator. So then in that process, I would multiply. This one is 3 and I need times 5. But I multiply by 1. Really, I multiply by 1. So 5 over 5 is 1. So I'm not changing anything. And over here, my 5 needs a 3. So I'm going to multiply by 3 over 3. Another way to say 1. So what happens is I get 5 over 15 plus 6 over 15. And now that I have a common denominator, right, here we go, I can add across the numerator 11 and the denominator stays the same. I'll write that down even. Add across numerator. I don't know how to spell that word. And you keep the denominator. Okay, so that is the way we learn how to add fractions when we were younger. So the same thing applies when we're talking about rational equations. And notice I have a number here that's written as a fraction. And back to that concept of any number written over 1 is itself. So if I asked you to write the number 4 as a fraction, you would say 4 over 1. And I'm reminding you of that because I have some whole numbers here. And anytime you have a whole number, I want you to write it over 1. So really, if I wanted to rewrite this all on one line, I'd have a over 1 minus 5 over a equals 4 over 1. And then I need to determine the least common denominator. And in any situation where you have a denominator of something, 1 and something, for example, I have 1 and a, my least common denominator is a. Okay? So as I'm looking at these, it looks to me like this is missing a. So I multiply by a over a. And this part here, 5 over a, negative 5 over a, isn't missing anything because it has a in it. And here I'm missing a over a. Okay, remember I multiply by a multiple of 1. A over a is 1. Okay, so when I multiply here, I have multiplying fractions, a squared over a. Multiplying across the numerator and the denominator. I don't have to multiply anything here. 4 times a is 4a. 1 times a is a. And now that I have a common denominator, I can add across. So I have a squared minus 5 equals 4a. Okay, and so as I'm looking at this, I'm thinking now, all right, well, let's see, how would I solve this? Well, if I told you a over 7 equals 4 over 7, okay, you would simply tell me that a equals 4. So how do we kind of do that with math? Well, the first thing that I need to do is multiply both sides by a. Now notice this time I'm not multiplying by a over a. I'm just multiplying by a. Okay, I'm doing an algebra move. This is multiplying by 1. This one is an algebra move. And I say that because what happens is when I do an algebra move, whatever I do to one side, I have to do to the other. And when I multiply both sides by a, I clear the denominator because a over a is 1. A over a is 1. So here I'm left with a squared minus 5 equals 4a. We have not solved yet, but this to me looks a lot like a quadratic that I think I can solve. So I'm going to move this over, and I have a squared minus 4a minus 5 equals 0. Okay, this is something I think I can solve. I can factor this. So factors of negative 5 that add to negative 4, a minus 5, a plus 1. And then to solve, I'd have a equals 5 and a equals negative 1. All right, whew, take a breath. You finished that, but you're not done. Why are you not done? You have to check. So I think I put it up here in my iCans. Oh, I didn't. There's some things here called, let me use pink for this, extraneous solution. And that means answers that don't work. I need to decide, and going back to this up here, looking at this equation, is there a number that I could put in the denominator that would cause a lot of issues? And that number would be 1, or not 1, I'm sorry, that number would be 0, right? And so I'm gonna write that over here. There's a restriction here. A cannot equal 0. And I cannot equal 0 because then I would have 5 over 0, and that would be horrible. We can't do that in math. But it looks like I didn't get an answer of 0, right? I got 5. Does that work? 5 minus 5 over 5 is 1 equals 4. That one works great. Negative 1, 5 divided by negative 1 is positive 1. So negative 1 plus 5 is 4. Also works great. Does anything wreak havoc and cause my denominator to turn to 0? No, that's good. I can keep both of these answers. Both of these answers work, okay? This one has no extraneous solutions. Look at, you see that word extra in there? I didn't finish writing it. But both of these solutions work. So that word extraneous really focuses on extra solutions that don't work at all. So you always need to be checking for those. So my hope here was that we would work our way from like easy-ish, easier-ish to hardish. So I have some more for us, of course. Isn't that how math always goes? The first one seems pretty easy, and then I let you do the homework, and they all seem incredibly difficult. Okay, so I'm looking at this, and I'm thinking, do I know x plus 5 and x minus 3? Do I know this number x? I don't. So my least common denominator in this case is going to be multiplying these together because I don't know what these numbers are. So x plus 5 times x minus 3 is my least common denominator. Okay? I don't need to multiply them right now. I just need to focus on using them to solve. So this side is missing x minus 3. Remember, this really is just 1. Okay, x minus 3 divided by x minus 3 is 1. And this side is missing my x plus 5. And I say missing because these are factors. So just like when we did 15, I had 5 and I needed to multiply by 3 to get 15. I have x minus 3 and I need to multiply by x plus 5 to get my common denominator. So now we're going to start simplifying a little bit here. I'm going to multiply these two things together. So I have 9x minus 27 over, and again, I am not going to simplify, or I'm not going to multiply this common denominator out, equals, and then I'm going to multiply these two together, 3x plus 15, and I am not going to multiply the common denominator out. And I'm not going to do that because I'm going to use that thing that I used last time, that algebra move, to kind of get rid of my denominators. So I'm going to multiply both sides by this. This is that algebra move. Because algebra multiplying by something divided by itself changes it to 1, clears it to 1, makes it equal 1. So now what I have left is 9x minus 27 equals 3x plus 15. Okay, and this doesn't look like a quadratic. I'm not going to have to factor. I'm just going to kind of solve regular, if you will. So 6x minus 27 equals 15. I'm going to add 27. So 15 plus 27 is 42. And then I'm going to divide by 6. And I get x equals 7. Okay, now we kind of need to do that thinking about what, if anything, can I not put in the denominator? Okay, what would make my denominator 0? That's bad, right? So I'm looking right here now. Back at my original equation. I do have some restrictions. X could not equal -5, and x could not equal +3. That's because if I plugged -5 in here, I'd have -5 minus 5, and that would go to 0. Eek. Okay? Same with here. If I put 3 in, this side would have 0 in the denominator. Eek. Okay, we don't want that. So, does 7 work? Well, plug it in and try. I'd like you to do that. Is 7 in our restrictions? No. So there are no extra solutions for this one. All right, last one. Hardest one of all, so far at least. Okay, and then I'm going to highlight this. All right, because when I see problems like this and I'm solving these rational equations, the first thing that I need to do is factor. So I'm going to rewrite this. Because what I noticed is, and I'm going to write this, this is factorable. And I think that I actually wrote this problem down wrong because I wanted it to be x squared minus 4x. So of course you can change that. Sorry, I was checking on something and I did because I wanted it to be like this. And when that happens, then I have what matches here. So like this, I have an x and an x here. An x minus 4 and an x minus 4 here. All right, so now that I have my problem squared away here, I need to think about my common denominator. And then again, if you want to right away think about those restrictions, I can see here that x could not be 0 and x cannot be +4. And I hope that you see that too. I'm going to highlight that in a different color. If I plugged in 0 here, I'd be in big trouble. And if I plugged in 4 here, I'd also be in big trouble. So let's just kind of see what we can think about as our common denominator. Now, are x and x minus 4 alike? I don't know. Like x could be 9, then x minus 4 would be 5, and to get a common denominator, I'd have to multiply them. So the same thing is going to apply here. My common denominator is going to be these two things multiplied together. What I highlighted in green, and then what I highlighted in yellow. Okay, so now I need to think about, I have x, I'm missing x minus 4, I'm missing that yellow piece. And in my next one, 3, I have x and x minus 4. I have the yellow piece, I am missing that green piece. And on my -16 term here, I am not missing any of those. Okay, so I don't have to multiply anything over here. I'm going to multiply out anything in the numerator. I am not multiplying any common denominator out. I'm just going to kind of leave them. Okay, so x minus 4 times x plus 4, I get x squared minus 16 over my common denominator. Okay, and then over here I have 3x over my common denominator. And I have equals -16 over common denominator. And then I'm going to do that algebra move where I multiply everything over here times my common denominator and everything over here times my common denominator, because then I know that this happens. So I solved this last bit here, starting here. Well, not recording, but I'm hoping you can follow here, that I moved this 16x over by adding 16. I was left with x squared plus 3x equals 0, and I factored out an x. And what happened was I got an extraneous solution. Because as you can see in orange, the x equals 0 matches one of our restrictions. And if I plugged 0 in, I'd have x plus 4 over 0. Eek, can't do it. That's one of those extraneous, didn't finish spelling it, solutions. So the only solution that works here is this one here that I circled in purple and I'm now outlining in pink a little bit. So 0 is an extraneous solution, and the only solution that works is x equals -3.